Good morning and welcome to our exclusive webinar on high voltage pulse generators and power supplies. I'm Alan Gonzalez, your host for today's session and the Vice President of Sales and Marketing. I'm thrilled to have you join us for what promises to be an enlightening and engaging presentation. Today, we stand at a pivotal moment in the field of high voltage technology. The recent acquisition of Directed Energy Inc. (DEI) by Berkeley Nucleonics marks a very significant journey toward innovation and excellence. This merger not only enhances our capabilities, but also broadens our horizons in the realms of high voltage pulse generators and pulsed laser diode drivers. Furthermore, we're excited to introduce our new partner, Heinzinger. They offer the EVO Series high voltage power supplies. These state of the art units represent the pinnacle of reliability and performance, setting very new benchmarks for the industry. To give you a first hand look at the cutting edge technologies, we will have our esteemed engineers, Edgar Guzman and Cameron Simmons, perform a live demonstration. They will showcase the unique features and applications of our high voltage pulse and power supplies, offering insights into how these can revolutionize various sectors. But before we proceed, here are a few reminders. Please feel free to submit your questions at any time during the presentation. We will have a dedicated Q&A session at the end where our speakers will address your questions. This webinar is being recorded and a replay will be available for those who wish to revisit the content or share it with colleagues. Without further ado, let's embark on this electrifying journey into the future of high voltage technologies. Edgar, Cameron, take it away.
Thank you for that introduction, Alan. My name's Cameron Simmons. I'm an applications engineer here at Berkeley Nucleonics. I mostly focus on our high voltage and high current pulse generator lines. I've had a lot of experience working with customers to try to make their projects work with these, and I've gone on a lot of customer visits and gone in the lab and helped people troubleshoot these. So um, I've gotten a good overall idea of sort of what these units are used for. Uh, so today I wanted to talk to you about uh, the main uses, and then I'll delve a little bit deeper into some specific applications for our high voltage pulse generators. Um, so a main application that we've seen throughout the years is plasma discharge testing. If you go online, you can find numerous technical notes and academic papers that mention our PVX 4110, which is used is our 10 kilovolt unit, and that's used to generate plasma. Um, a lot of people have used these in their research, and obviously plasma itself is a very wide field of study. So one thing we've seen is testing plasma effects on atmospheric gases. Someone recently actually acquired one of our units and is in the process of writing an app note, which should be up pretty soon, about nitrogen fixing. And this is a chemical process by which molecular nitrogen is exposed to a plasma arc, and this will change its properties in a way where it can be converted into ammonia. And so, this also has industrial applications for, soil and aquatic systems. We've also, I worked with a customer somewhat recently that was using our PVX 4110 in a flaring system. which is for gas refineries and pipelines, which basically when you off gas these chemicals, you need to burn them in order to not release these compounds into the atmosphere. And they would use our PVX 4110 to generate plasma, which would be the ignition source for these gases. Uh, Another very interesting application that I've seen is mass spectrometry. So, in a lot of different kinds of mass spectrometry, our high voltage pulse generators can be used. Uh, Recently, I went on a visit to a national lab where they were using our PVX 4141 to do velocity map imaging. And velocity map imaging is a type of time of flight mass spectrometry that it goes a little bit deeper than most time of flight. So instead of just accelerating the compound and then judging its velocity and distance traveled, it actually can judge the reaction that created that compound. And that gives researchers an idea uh, on certain attributes of the reaction, as well as the quantum effects of this reaction as well. So the researcher there told me that this unit is literally perfect for that. So it's interesting to see our units used in such cutting edge research like this. Um, and another visit that I went on recently was actually to a certain electric car company that's using our PVX 4130 to drive their electric motors. And we got to see them testing the new motor designs, and the fast switching and high voltage really made this ideal for their testing. Um, and as I go throughout these applications, you'll see that the fields that they're used in are very vast and disparate. Uh, these pulsars really do have a lot of application in a lot of different industries, um, and so we've seen them be very useful to people. So moving on from motor testing, we actually have seen them used a lot in different aspects of semiconductor manufacturing even. So one unit in particular, our PVX 2506, is purpose built for something called IV testing. This unit can deliver 50 volts at 10 amps, and that's used to basically ramp up the voltage and current that's run through a semiconductor material, and then that will give you a characterization of that material and how it will react to certain signals. Um, Another different aspect of semiconductor manufacturing that other units were used in is solder reflow of wafers. So when you have multiple layers on a semiconductor board, they have to be soldered together, and some of our high voltage pulsars can actually be used to pull that extra solder away once the wafers have been heated and the solder's been melted. And I did a visit with them recently, and they showed us their setup, and it was really, really cool. It was very interesting. Um, so again, even more very different applications here. We have biological testing. Um, we worked extensively with a company that was using our PVX 4150 units in order to do imaging of tissues. Um, so it was used to basically identify and analyze certain cells. It's been used for tumor biopsies and evaluation of immune cells, um, identifications of proteins, um, and even other biological applications. We had another customer that was actually connecting the output of the PVX 4110 directly to deionized water, which contained cells in that solution. And they were trying to learn about what the effects of that strong electric field would be on the cells in that solution. Um, and I mean, this is these are just short examples. We've gotten a lot of different inquiries regarding biological testing. Another biological application has been cell ablation. So they'll take cardiac tissue and they can actually repair parts of the heart by applying short biphasic electric pulses to these tissues. And uh, the way the signal is shaped will actually determine uh, whether the patient feels pain or not. So that was really interesting to delve in with that customer on that, and how directly it affected the experience in this medical application, um, which I did not expect that these units would ever be used in medical applications, but they certainly can be. Um, Even optical applications, we've seen lots of that. The PVX 4110 again is great to drive Pockle cells. Um, and Pockle cells are optical devices that are essentially a crystal where when an electric field is impressed across it, it'll change the bifurengence properties of the crystal, or in other words, how light actually travels through the crystal. And this can be used in general optical testing, and it can even be used basically as a high-speed shutter, um, because the light can be instead of it relying on like a mechanical shutter, you can actually make the light. You can polarize it so the light either passes through or doesn't pass through based on an electric signal. So that's really the highest speed shutter of all. Um, and obviously, Pockle cells are the main component of electro-optic modulators, which are used in, well, for one thing, Q switching, where like a low power laser beam will be directed into the material, and then it the optical power basically builds up in the crystal, and then when you apply a pulse and you change that bifurengence, then all of that power is released in a short, very, very high power laser beam. And I mean, Q switching itself has many, many applications. And I would say the most general application, but something we really have seen a lot of, is component and material testing. So because we have units that will go up to 10 kilovolts, we've seen a lot of customers do, for instance, dielectric withstand testing, where they'll test their capacitors and they'll test where the breakdown of that dielectric material will occur based on voltage, and just general component voltage limits. Um, and the good thing about that is there's a current limit on all of these. So if you apply a voltage and you short your component, the unit itself isn't going to sustain any damage, because it's it's designed to shut down if it sees a short at its output. So it's a very safe unit to use as well. Um, Wire and insulation testing is another huge part of this. So testing the insulation of a wire and making sure that you're not going to melt the wire or experience arcing when you apply a certain amount of voltage to it. So it's really, really helpful to a lot of component manufacturers. Um, so you can tell as I'm going through this, it's just, biological, plasma, there's really so many industries benefit from these pulse generators. And over the years of working here, it's just been really exciting to see, glimpses of these really cutting edge technologies, and how these things that you only read about and see in documentaries, how it's actually being done, and meeting the people that are doing it has really been really exciting to me. So um, later on in this webinar, we're actually going to be doing a live demo with a new exciting product that we have, the Heinzinger EVO power supplies, which can be paired with our high voltage pulse generators. Um, so we're going to do a little demo. We're going to program in a voltage ramp, and hopefully you'll stick around for that and you'll see that. But actually right now I'm going to go ahead and turn it over to Edgar. Uh, Edgar Guzman is another one of our engineers, and he's going to give you a little bit more specific knowledge on this product line. So which units have certain specs, which units are useful for certain applications. He's really become an expert on these as well. So then after that, we're going to do the demo. So I'll turn it over to Edgar right now, and thank you for joining us today, and thank you for listening to me.
Thank you, Cameron. I'm Edgar Guzman, one of the application engineers here at Berkeley Nucleonics, and I'd like to introduce you to some of our high voltage pulse generators known as the PVX series. So we have voltages ranging from 50 volts all the way up to 10,000 volts. And as you can see on the slide here, we've listed a few of them, and they all have different numbering, but we refer to them as the PVX series, and they have different applications and different uses depending on how much voltage you need, how much current you need. So if we take a look at this chart here, we have the PVX 4110. That's our biggest unit, capable of doing 10,000 volts into a capacitive load. Um, it can do a 200 nanosecond minimum pulse width and up to 10,000 kilohertz, and that's our largest amplitude pulse generator. So if you're looking for anything higher than that, you can give us a call, send us an email, and see if there's anything we can do to accommodate. And we may have solutions that you guys haven't thought of. So that's one thing that we're good with doing, is picking and helping you pick different models for your application. So as we go through these different units, you'll see most of them are designed for capacitive loads. So whether that be parallel plate capacitors, Pockle cells, time of flight mass spectrometers, things like that. Just the voltage level is kind of the difference, and the specifications of pulse width and max frequencies. So next we have the PVX 4150, and that's a 1.5 kilovolt pulse generator, and it's bipolar, so it does 1.5 positive or negative. But like that's absolute value, so you could do 750 to minus 750 to get your 1.5 kilovolt, or anywhere in between that. And that has a minimum pulse width of around 60 nanoseconds, and that kind of goes hand in hand with our PVX 4141, which is our 3.5 kilovolt bipulse high voltage pulse generator. And it's the specs are very similar to the 4150, except that it can do the 3.5 kilovolts. And then we have our in between unit, which is our PVX 4130. It has specifications much more similar to our 4110, but it can do 6 kilovolts bipolar pulse generation. And it also has a 200 nanosecond minimum pulse width and about 10 kilohertz max frequency. If you need the higher frequencies, we would recommend normally going with the PVX 4150, 4141. Those go up to 30 kilohertz, in the case of the 4141, or up to 100,000 kilohertz, 200,000 kilohertz for the PVX 4150. Once again, it depends on the size of your load. These can also be used with resistive and inductive loads, but there's some caveats there, and you would need to speak to us before running those loads, just so we can ensure that you stay within the safe operating area of these units. We also would like to introduce the PVX 2506. This is a fairly special unit because it's capable of doing not only relatively high voltage but high current. So it does 50 volts and 10 amps max. So it's mainly used for IV testing of semiconductors, but anywhere where you need to drive something with more than a TTL voltage, but and higher current as well. That's where you would use the 2506. So these are just some of the units that are in our PVX series. We also have some PVM units, which are smaller module based that do a varying level of voltages, 950 differential. So we have one output that's 950 and another output that's negative 950. And then we have our PVM 1001 positive or negative that does 950 but is designed mainly for resistive loads. So if any of if you need high voltage or anything like that, give us a call, an email, and we can discuss your particular application and see which one of our units best fits what you're doing. And we love to hear your applications. As Cameron spoke about earlier, he gets to talk to a lot of our customers with their applications with our PVX series and our current generators, so our PCXs and PCOs. So we do really enjoy talking to you guys about your applications. Some of the key features of the EVO series are the fact that it has the bipolar option, so you can have a singular unit that can do both the negative and positive outputs. It also has other optional functions such as a ramping output, so it will ramp to your voltage from zero in a time that you set within the limitations of the switching of the actual EVO unit. And those specs are all in the data sheet if you'd like to take a look at that. Um, and then if you purchase the units together, so if you purchase a 4150 with an EVO 1500-1400, then we can pair the actual cable to fit into our PVX because each PVX unit has a different connector, whether it be SHV, Kings, or a much higher voltage LEMO connector. So if you buy them together, we can pair them so that you can connect them the moment you get them. We also have other components or other products that we can sell that can be used with our PVX series as well, like to gate them, to time them. So we have our DDG product line. So give us, give us all the information you can about your application, and we can give you a full system that outputs the voltage you need for your application specifically, and just that the best fits you and your actual, what you're doing. That's If you have any other questions about the Evo or any of our PVXs, we're going to have a Q&A afterwards, after our live demo, which is going to be done by Cameron here soon, where he will pair our Evo with a PVX unit and show you how easy it is to use, not just the PVX, but the Evo. Uh, it has a nice digital screen, very easy to use. Turn up the voltage, turn it off. It has a lot of protections, whether that be overcurrent, over voltage, and those are all settable. So you can have limitations just for safety standards in your lab or in your whatever environment you're using these in, so that you can best protect yourself and your colleagues. But that will be showed off by my colleague Cameron here in a little bit. And this I'm going to send over to my colleague Cameron, who talked to you guys earlier. He has a little more information on the Evo, as well as he's going to do a demo for us showing the Evo power supply hooked up to one of our PVX units. So.
Hey, Cameron here again. Edgar has gone over some of these products and the Heinzinger Evo especially, but I just wanted to touch on a couple other things. So really use cases, there's a lot of applications in semiconductor production, verification, component testing, and because of its connectivity and the fact that you can automate it, calibration processes also. So it's a really versatile power supply, very safe. It has a lot of protections and a lot of sort of forensic data you can get from. So when something fails, there's a whole litany of flags that you can look in the menu at, and it'll tell you exactly what happened, why it failed, and that's really invaluable for troubleshooting for in certain situations. So, and talking about competitors for these units, another power supply brand that we have used in the past is Glassman. Um, They do make really good power supplies. Not quite as good, but they we've seen extremely long lead times from them, more than a year, if that. Our customers were really struggling to find high voltage power supplies for PVX units, which is why we reached out to Heinzinger and are now their exclusive US rep. And that way, when our customers order a pulse generator, they can actually order a power supply to power it as well. So that issue's been solved, and I'm not sure if Glassman's going to ramp up production and be able to get their lead times down, but for now, we've offer what I believe are superior power supplies, and at about the same price. So, and as Edgar mentioned, please contact us. So if you ever are interested in an EVO power supply, or you have one and you're wondering about setup, please just give us a call or email. We're happy to help you with this. We've become experts in them now. So anyway, moving on from the introduction of products, we're now going to do the live demo. So you'll see me and Edgar setting these up and using it to drive a capacitive load. And we're going to do a couple interesting things with the EVO as well. So I hope you enjoy. Hey, Cameron from Berkeley Nucleonics again, here to show you our PVX 4110 and Heinzinger EVO power supplies. The PVX 4110 has a maximum output voltage of 10,000, maximum peak current of around 30 amps, but average current will be such that it will be under 100 watts, so in a few milliamps. We're going to be using this today with the Heinzinger EVO as the power supply, and we're going to show off some of the ramping functions, as well as the different connectivity and control options that we have. And you'll be able to see that the Heinzinger EVO is really a very versatile power supply, and very good for lab applications, complex setups. We're even going to show how you can incorporate the EVO Skippy commands into a Python script. So if you have a fully automated test setup, this will incorporate seamlessly right into it. That being said, let's get this demo set up. So I'll go ahead and connect the negative high voltage into the back. This uses a 12 kilovolt LEMO connector that's actually lockable. So you can go ahead and put it in, and then go ahead and screw this forward, and this stops it from being able to be pulled out. Okay, so now with our high voltage connected, we can go ahead and plug the high voltage pulse output into our load. This is also a 12 kilovolt LEMO connector. And these cables come with the unit, 3 of them, 2 for the high voltage input and 1 for the high voltage output. The cables come unterminated, so you can interface them with whatever load or power supply you may have. Here's the main screen on the Heinzinger EVO. Here we can turn the high voltage on and off, and here we have our menu. You can see that there is over voltage and over current protection. There's also a hard limit for redundancy. We have our ramp function. There's actually arc protection that we can turn on, and then we can have that shut it down or just warn us. Here we can select how we're going to control it externally. So right now we have it set to front panel control, but we can change that to Ethernet or Ethernet HTTP if we're using the web interface, or RS-232. And actually this unit does not have analog control installed.
but it's also possible to control the output high voltage with a small input analog control voltage. Go into the interface menu and we can set our IP address and ports if we're using serial or Ethernet control. In the setup menu, we can set overcurrent protection on or off, whether it discharges or not, buzzer stuff, mostly just user settings here. So we can actually lock this unit and require a PIN either to use it or to change any of these menus. So if we can make sure no one changes the overcurrent protection or limit. And this can be handy if you have a lot of different people using the supply and you don't want anyone to break it or hurt themselves. I have ID. So this shows the ID of the EVO and it gives us an idea of what the firmware is, and yeah, it looks like that's basically it. And here we actually have the info and event log. This can come in handy if there's any kind of error or if the unit overcurrents and shuts down. We can actually go into here and see what happened. So we can see if it was tripped because overcurrent or over voltage, was there a fault, or did the interlock just come out? So it can kind of give us some forensic details on a failure, which can really help to troubleshoot and diagnose problems. And that's it. Okay, so we're going to be measuring using our model P4017B USB oscilloscope. Here we have our high voltage probe plugged into channel 1, and data and power is all being taken care of with just one USB-C cable. Okay, here we have our Python script, which we will be using to control the Heinzinger EVO. You can see, we'll just go ahead and open the resource, set the baud rate, the timeout, and then we're gonna query it just to initialize it. And then we can write output off, set the voltage to 400, and then we can set the ramp and initialize at the end of the script. Okay, so now we're gonna set up the EVO to be controlled through the web-based user interface. So we're going to go to Control and Ethernet HTTP, and then we're going to go back and we're going to go to the interface menu, and this is going to show us our IP address, and we're just going to go ahead and type that IP address into our web browser. Okay, so now I'm going to show you how to use the web-based graphical user interface for the Heinzinger EVO. We're going to start by typing in this unit's IP address, which is set to 192.168.1.100, and we have the home screen here, and we're going to go ahead and click this, and it's just connecting here, and now we can see it's connected automatically, and we are controlling it with Ethernet HTTP. System is okay, temperature is okay. And here we can see our set voltage and actual voltage. So now we can go ahead and set those here. We'll set it to 1000 volts. And we'll go ahead and limit the current to 20 milliamps. Press enter. So now over in this side we can see that these are now our set voltages and currents. Now that those are set, I'll go ahead and start the ramping. I'll show you how to set the ramp function from the front panel. Go into the menu, go to the ramp section, you can select on, and now we can change the volts per second, so how quick the ramp is. I'm going to go ahead and change that to, and we can, coarse or fine. I'm going to set that to 25 volt per second. Okay, now we're going to go ahead and show you the trace view through the USB oscilloscope. And here you can see it's at 0 volts, and I will go ahead and start the ramp right now. So the divisions are 200 volts per div, so you can see it's about 25 volts per second. You can see it ramp up to 1,000. And you can see the statistics in the corner. We have V max of a little over a kilovolt. We can go ahead and zoom in on that. Actually, we can look at the rise time more accurately. Looks like our rise time is pretty perfect, 25 nanoseconds. Now, if there's an issue and we want to quickly turn the voltage down, we can go ahead and disable high voltage and it will drop very quickly. Or we can either from the front panel or through a command decrease the voltage of the EVO to 0 and it will ramp back down at the same rate. So here the EVO is set to 0 and it just is going to take some time to ramp back down to that. This can be very valuable in testing. Sometimes you want to test the ramp up and the ramp back down, how things react. We could also ramp it down to negative voltage if we wanted to. So a lot of possibilities. One of the great features of the 4110 is that if you don't have a high voltage probe or you don't want to probe your load directly, you can actually use the voltage monitor on the front panel. This is a small representation of the pulse, and you'll be able to see from this demonstration that if you scale it correctly on your oscilloscope, it will look identical to the actual output pulse. That way you can use this low voltage that you can trust is a representation of your signal without actually dealing with any high voltages going into your oscilloscope. So right now I'm going to start the ramp, and you can see that the main output is in red, and I'm putting the voltage monitor into channel 2, which is shown here in yellow. So you can see as they ramp up, they're virtually identical. They even share a lot of the same features. You can still see the same overshoot, and the same aberrations. So it's really a voltage monitor that you can trust.
Again, it looks like we have some questions. This is the time to ask your questions. I think Andre has a question for our engineers.
Wonderful.
Do you plan to reduce pulse width and rise fall times?
No plan specifically right now. The pulse width and rise, especially the rise time and fall times, are pretty competitive. They're already a lot faster than a lot of the units that are in direct competition with them. So we have no plans so far, but if you have some particular needs, there's a possibility of seeing what we can do.
Right. And again, there, like Cameron had discussed, there are a wide range of experiments, there are a wide range of applications, requirements. So if you do have a specific need, by all means, feel free to give us a call or go to our website, berkeleynucleonics.com. We could definitely support you to kind of work within your own kind of demands or needs. But that's good. Okay. Any other questions for our esteemed engineers? Don't hold back. Any other questions? Right,
Well,
so
maybe
yeah.
maybe in the meantime, I was actually speaking to one of our customers yesterday, who I think is in attendance today. He is going to demo the Heinzinger EVO 10 kV unit, and he was wondering about building a safety interlock system. And I thought that that was a good example of how versatile these units are, and so I thought I'd maybe talk about that a bit. I think, would I actually be able to share my screen here? Maybe not, but oh, let's see here. Yeah, it looks like I can share my window. Okay, so this is a picture from the manual of the Heinzinger EVO. And as you can see, this is the I/O terminal in the back, and this just gives you a simple pin out. With the analog I/O option, you can see pins 7, 8, 9, and 10. They can actually be used to control the high voltage. It scales, I think it's like 10 volts or something like that is the full voltage. But here, let's talk about pins 1 and 2. So this is an emergency stop circuit. It's very, very low current, very low voltage, and normally closed. And so our customer was wondering if they could create not only a door interlock for their high voltage cage so that the power supply will automatically shut down when the door is opened, but to have a secondary switch that's an emergency stop button that they could have in the control room itself. And both of these would automatically shut down the unit. And as some of you could maybe infer here, it's actually really easy to set up. You would just put the button and the door switch would both be normally closed switches. And again, very low current, very low voltage, not a lot of requirements as far as which switch you would have to choose. And then they would just be two in series so that if the door was ever open or the button was ever pressed, that continuity would be broken and the supply will automatically shut down. So that was a great way of showcasing some of the external features of this unit.
Nice. Very nice. It looks like we have another question from Arnaldo. What are the max inductive loads?
Ooh, that's a good question. We do not get a lot of requests for inductive loads. So I would have to look into that a little bit. I know for these units, I think they come in 2,000 watt and 3,000 watt models. So depending on what the impedance of that inductive load is, you would have different power dissipation. Yeah, so I would have to look into what the equations there would be.
We'll send it. Yeah, we could definitely send that after the
Yeah,
webinar to everyone that was
I can follow up
participating.
on that.
Okay. All right. Well, that concludes the webinar for today. We want to thank everyone that was a part of this, our marketing team, the engineers, obviously the attendees. On behalf of everyone here at Berkeley Nucleonics, thank you for coming. We will do our very best to support you now and in the future. We have representatives, engineers here in the U.S., in California, in the East Coast, and in Europe. So if there were some questions that we did miss or some that you do come up with, by all means, feel free to reach out via www.berkeleynucleonics.com. All right. Sounds good. All right. Thank you, everyone.